Hey, so in this video we are going to discuss about an interesting category of the operator that is called as miscellaneous operators category. So in this category what we do is we place the operators which don't really fit in other 5 operators category. Okay, so let's quickly see what all operators I have placed in this category. So in this category I have placed 3 operators: size of operator, then AND operator which is address of operator, and then conditional operator which is only ternary operator present in C++. Let's quickly revise the names. First operator in the miscellaneous category is size of, then we have address of operator which is represented by AND symbol. Now this AND symbol is very common, so don't get confused with it. I am going to explain you what is this address of operator right now, don't worry about it. And then finally we have conditional operator. See, in this category we have leftover operators, right, which don't really fit in the categories that we discussed earlier, but there are few more operators which are still left, which are not even there in the miscellaneous category. So we are going to discuss about such kind of operators as and when we'll require them, because there are so many operators, as I'm again repeating, there are so many operators which are still left over. We haven't added them into any category. We are going to discuss them as and when we will require them, so don't worry about those kind of operators. So let's start with the first operator, the size of operator. Size of operator is very interesting and sometimes it's very useful. Size of operator, it's, as its name suggests, it is used to get size. Now size of what? So we can get size of different things. So we can get size of a data type. So let's say you have we know that we have different data types, like we have integer, we have char, we have float. So basically we are talking about the primitive data types here. So you can actually use size of operator on the primitive data type keyword and you will get size of that data type. What size your machine is going to allocate for that particular data type's variable, you can get that with the help of size of operator. Isn't that interesting? You can also use this size of operator on variable. Let's say you create a variable of some data type, you can also use size of operator on that variable to get size of that variable. What is size of that variable in the memory? And you can also use it on a constant. Let's say you have constant like let's say 2 or small a, something like that. You can also use size of operator on some constant to check what is its size, what size compiler is going to allocate for this kind of constant. Okay, it's very interesting, right? See, I'm going to show you size of operator in action when I'll move to the Visual Studio Code. Right now we are just discussing a theoretical part about the size of, or I'll say all miscellaneous operator. Main thing about the size of operator, and you must have guessed it, it's a unary operator. It will need only one operand in order to perform its operation. Okay, so either it's going to be a data type keyword, or it's going to be a variable name, or it's going to be a constant. So you can give any operand from this list. Let's move to the next operator in the miscellaneous category. It is called as address of operator. It is represented by AND symbol. Okay, see, we also use this AND symbol for representing bitwise AND operator, but the difference is bitwise AND operator is a binary operator, whereas address of operator is a unary operator. So again, depending on how you write the operator or how you write the syntax, compiler will identify whether you are using it as an address of operator or you are using it as a bitwise AND operator. So how compiler is going to distinguish between bitwise and address of operator? Bitwise AND is a binary operator, address of operator is a unary operator. So what address of operator is going to do? See, whenever we create any variable, whenever we declare any variable, what happens is some memory gets allocated, right, for our variable. Now whenever we say that our variable gets some memory, where this memory is getting allocated, this memory is getting allocated in random access memory. Now listen to this very carefully. See, this random access memory is a byte addressable memory. So in random access memory you have multiple bytes, and we know that one byte is basically 8 bits. So you have multiple bytes, and what do we mean by byte addressable memory is for each and every byte there will be a unique address. So let's say you have 8 GB of memory. You can imagine how many bytes might be there in the 8 GB. So for each and every byte there will be some unique address. Okay, now whenever your variable gets some memory, your variable is going to have some addresses. Let me show you how. So let's say you create a variable of integer type. So let me just draw it over here. We know that for integer variable we get 4 bytes, right? So let's say these are our 4 bytes for our integer variable. Now each and every byte is going to have a unique address. Let's assume that, let's say first byte is having 100 address, then this one is going to have 101. See, addresses are going to be consecutive, right? So if this is 100, then this must be 101, then this is going to be 102, and this is going to be the 103. See, we are going to discuss about this entire concept. We have a separate module for this that is called as pointers. Right now I'm just giving you a high level overview. So for whenever you create a variable, your variable is going to have some addresses. Now in this case, as we have integer variable takes 4 bytes of memory on the modern machine. So for our variable we have 4 different addresses. Now out of these 4 different addresses, there is one address which is little bit special among all these 4 addresses, which is called as base address of your variable. So the address from where your variable starts, that address is actually called as base address of your variable. So in this case, from this address or from this byte your variable is getting started. That's why this 100 is base address of this variable. And what this address of operator is going to do, this address of operator is going to give you address of your variable. So whenever you create a variable, that variable is going to get memory, and for that memory there are going to be some addresses. So whenever you apply address of operator on the variable, you will get address, or you will get the base address of your variable. That's it, that simple it is. Okay, see, right now you might be having some questions in your mind that why we need address of a variable, why as a program we need to care about the addresses and all that. So whenever we'll go ahead in this course, there is a very special module, very interesting module that is called as pointers. In that module you will get a complete idea about why we need addresses and why we need to care about the addresses as a programmer. Right now don't worry about it, right now just remember what is this address of operator. Okay, now the third operator, that is the conditional operator. Right now I will not give you much details about this conditional operator because it's little bit different as compared to size of and address of operator. So right now let's not discuss too much about it, but right now just remember it's the ternary operator. So it will require 3 operands in order to operate. So with this, let's quickly move on to the VS Code and let's start with coding. Okay, so I'm on the VS Code now, and as usual I have written a basic code template. Okay, so I have included the header files, then I have used namespace std, and then I have written a main function with return 0 at the end. And then let's start writing our code over here. So let's first start with the size of operator. Let's see how size of operator works. I'll tell you the syntax of size of operators. So what you have to do is you have to write size of, okay, followed by opening bracket, and in the opening and closing bracket you can write your operand. Now in case of size of operator, there are 3 possibilities of the operand. First is you can write data type keyword. So let's first start with the data type keyword. See, let's say you want to know what is size of integer data type, you can write size of in bracket int keyword. Let's say you want to know what is size of boolean data type, you can write size of in bracket bool keyword. Okay, this size of is going to return you size in bytes. Okay, it's going to return you size in bytes. So we'll just need to print it on the screen. So we'll just write cout. Over here I'll write size of int. I write it in string so that we'll get better idea of the output, and then over here I'll write endl. All right, similarly over here also let's put size cout. So I'll write cout size of char, not char, sorry, it's bool, colon size of bool followed by endl. Now let's quickly see what is size of integer and boolean data type. So let's quickly execute this code. So before that, let me compile this code. So name of my file is misc.cpp. Let's quickly compile this and let's quickly execute this. You can see we are getting size of int as 4 and size of bool as 1. Isn't that interesting? Now we can also operate this size of operator on variables. So let's say I create one variable of float type, let's say float f. Let's not initialize it, that's fine. Let's create one more variable, let's say of double type, double d, and now let's apply size of operator on these 2 variables. So I'll just copy paste these 2 lines, I'll paste it over here. So over here I'll print size of float. So here instead of writing float keyword, float data type keyword, I will write variable name. Even that is fine. Over here instead of writing size of double, I'll write size of d, which is variable of double type, and over here I'll write size of double. Okay, now let's quickly compile and execute this code. Let's see what we get as the output. See, size of float is coming as 4, which is correct, right, as per our previous discussions, and size of double is coming as 8, which is again correct. So in this way you can use size of operator on variables. Now you can also use size of operator on constants. So let me just again copy paste these lines. Now instead of this f, what I'll do is I'll write 2.5f, which is a floating constant, right? And instead of this double, I'll write, let's say, 4.5, which is a double constant. Let's see what happens if we write it like this. So let's compile and execute this code again. Focus on last two lines. So over here we are getting size of float as 4. So 2.5f is floating constant, right? So size of floating constant is 4 byte and size of double constant is 8 byte. So in this way we are getting output for size of operator. I hope now you are pretty clear about the size of operator. It's pretty easy. You can pass it a data type keyword, you can pass it a variable name, or you can pass it any constant. What this size of operator is going to do, it is going to return you size of that particular data type. Okay, so let's quickly move on to the next operator, which is address of operator. Now this address of operator is again a unary operator, and this operator only works on variables. So it will not work on constants or anything. It will only work on variables. So for this demonstration, what I'll do is I'll create two variables. Let's say integer a variable, and let's create one variable. Let's say float. Let's say x, float x. Okay. Now let's see how we can write address of operator, or how we can use address of operator. So I'll write and a. So and a can be read as address of a. Okay, so basically and a will give you address of a variable. Similarly, if you write and x, so and x is nothing but address of x variable. So at current instance, whenever I'm executing this code, what is address of a, what is address of x, you can get that with the help of address of operator. So in order to print it on the screen, we'll have to write cout statement as we do always. So I'll write cout address of a colon, again insertion operator followed by endl, and over here I'll write cout address of x colon, again insertion operator followed by endl. Wait, there's some issue over here. Yeah, so this and came over here. Yeah, it's that simple. Address of operator is very simple to use. So let's quickly compile and execute this code. Let's see how we are getting the addresses. Addresses are interesting. So you can observe, see, we get addresses in this format. It's kind of hexadecimal format. So if you observe, this number is in hexadecimal format. So this is the address that we are getting for a variable, and this is the address that we are getting for the x variable. So in this way you are going to get addresses for your variables with the help of address of operator. So I hope now address of operator is very clear to you. It's pretty simple, very straightforward. It's a unary operator. You just need to supply one operand to it, and that operand is going to be a variable. You cannot give any other operand than a variable to address of operator. So with this, let's quickly move on to the next operator, which is conditional operator. Now this conditional operator is pretty interesting. So let me tell you syntax of the conditional operator first, and then we'll see some examples. So for conditional operator, you need to give 3 operands. So how we give 3 operands? Let me show you that. So you will first have to give operand 1, then you will have to write question mark, then you will have to write operand 2, then colon, then operand 3. This is the typical syntax of conditional operator. You will have to write first operand 1, then question mark, then operand 2, and then colon, and then operand 3. Now what is meaning of this statement? What is exact meaning of operand 1 question mark, operand 2, colon, operand 3? So it's very simple, very straightforward. Just focus very carefully. See how this operator is going to work, conditional operator, how it is going to work. See, as its name suggests, it is conditional operator. So there is this conditional word, right? So what is this conditional? So we have operand 1 over here. Now operand 1 is typically going to be some condition. Okay. Now what do we mean by condition? So remember in one of the video, I think it was in logical operator. So in that video I gave you one example. Let's say your father is going to give you BMW if you score more than 80% mark in 10th and more than 70% marks in 12th. something like this. So, okay, this is called as condition. So usually your operand 1 is going to be a condition, but it's not compulsory that it needs to be a condition. It can be literally anything. It can be something like let's say 1. This can be also your operand 1. So what is the basic idea behind this conditional operator is your operand 1 will be treated as a conditional expression. So this conditional expression operand 1 is going to be evaluated first. If operand 1 is evaluates to true, then what is going to happen is result of this conditional operator is going to be operand 2 in this case. See, very simple, focus very carefully. See, if operand 1 evaluates to true, this operand 1, if it evaluates to true, then result of this complete expression will be operand 2. If operand 1 evaluates to false, then result of this complete expression will be operand 3. That's it. Okay, as simple as that. Let's see a simple example. So what I'll do is I'll write cout insertion operator, in bracket I'll write C1 question mark, let's say 1 plus 2 colon 3 plus 4 followed by ENDL. For now I'll comment out this entire code. So let me just comment out this entire code because it's not needed now, and let me also clear the terminal. Till now you focus on the expression that I have written. So what I have written is I have written operand 1 as 1, operand 2 is 1 plus 2, then operand 3 is 3 plus 4. Okay, so basically any operand can be any expression. You can give any expression for the operand. Okay, now let's quickly compile this code and let's see what we get as the output. So I'll write g++ miscellaneous.cpp and then I'll execute it. You can see we are getting output as 3. Now why we are getting output as 3? So as I have told you in the description of this operator, if operand 1 evaluates to true, now let's see in this case what is operand 1, what it is evaluating to. So in this case my operand 1 is 1. Now 1 is a truthy value, so basically operand 1 is evaluating to true in this case, and that's why whenever your operand 1 is true, result of this entire expression, result of this conditional operator is going to be your operand 2. Now what is your operand 2 in this case? In this case your operand 2 is 1 plus 2. So 1 plus 2 will be calculated, this expression will be again evaluated as it is another expression. So this small expression will be evaluated and answer of this expression is nothing but 3. That's why you are getting 3 as the output. Let's quickly see what happens if I write, instead of this 1, if I write 0. Let's see what happens. Okay, so let me quickly compile and execute this code. Now in this case we should get 7 as the output. Why? Because in this case operand 1 is evaluating to false, because 0 is a falsy value. So result of this conditional operator should be operand 3. And what is operand 3 in this case? It is 3 plus 4. That's why in this case we should get 7 as the output. Let's quickly see if we are getting 7 as the output or not. So you can see we are getting 7 as the output. So in this way our code is working properly. Our conditional operator is giving us a proper output. Now let's write a sensible code. Let's write some meaningful code. So I'll give you one condition. Okay, I'll give you one simple problem. Let's say you are getting one number. You are getting one number and you want to check whether that number is even or odd. Okay, so you want to check if the number is even or odd. If the number is even, let's say if number is even, then you have to print even on the screen. If number is odd, in that case you want to print odd on the screen. This is your task. Okay, let's see how we can do it. So for that what I'll do is I'll declare one variable, that is number, and let me initialize it with some even value for the first explanation. Okay, so let's try out with even value first and then we'll check for odd value later. Now what can be the condition? I mean what condition we can create so that we can find out whether a given number is even or odd. How we can find out whether a given number is even or odd? It's very simple. It's a very simple problem to solve. So what we do is we take modulus of given number with 2. If we get remainder as 0, so what we do is we take modulus of number with 2. Now why we are taking modulus with 2? See, basically we can say that a given number is even number if it is completely divisible by 2. right? And a given number is odd number if it is not divisible by 2. This is the basic definition of even and odd number, correct? So if we divide number by 2 and if it is getting completely divisible by 2, in that case what will be the remainder? In that case your remainder is going to be 0, correct? If the number is completely divisible, then remainder will be 0, that's correct. So I can say that if number mod 2, if it is equal to 0, we know that this modulus operator is going to give us remainder of the division. So basically if the remainder is 0, that basically means that number is completely divisible by 2, and that basically means that number is a even number. Okay, so we can say that this is the condition for even number. Similarly, what is the condition for odd number? So we can say that if number mod 2, if the answer of number mod 2 is equal to 1. See, you take any number, let's say 10. If you divide 10 by 2, the remainder is going to be 0. Let's take another number, let's take 11. If you divide 11 by 2, the remainder is going to be 1. So whenever you divide any number by 2, there are only two possible remainder values, 0 and 1. See, this is true for any divisor. Let's say you are dividing by 3, then the possible values for the remainder will be 0, 1 and 2. So in our case, we are dividing by 2, so possible remainder values are 0 and 1. If the number is even, then your remainder is going to be 0. If the number is odd, then your remainder is going to be 1. Okay, so if number mod 2, if your remainder is 1, then we can say that your number is odd. So this is the basic idea behind finding whether a given number is even or odd. Now how we can write this thing in the conditional operator expressions? It's pretty simple. So what we have to do is, we have to take any one of these expression, either evens expression or odds expression. So let's pick up evens expression. So what we will do is, as the first operand of the conditional expression, we will write this condition, that is number mod 2 equal to 0. I'll write this condition as the first operand, then I'll give question mark. Now if this condition is true, then we can say that the number is going to be even number. Okay, so in the operand 2, so basically operand 2 will be the result of conditional operator if operand 1 is true. So if this condition is true, we can say that the number is even number. So in operand 2, I will give even. I'll write even over here. Colon, in operand 3, I'll write odd. How this is going to be executed? Just focus very carefully. See, first this condition will be checked. If this condition evaluates to true, that means your number is an even number, then output of this conditional operator is going to be operand 2. In this case, what is my operand 2? In this case, operand 2, sorry, I made one small mistake over here. See, even should be enclosed in double quotes instead of single quotes, because it's a string, not a character, right? So that was a small mistake. Okay. So if this condition evaluates to true, then result of this conditional operator is going to be even, and if this condition evaluates to false, then result of this conditional operator is going to be odd. Okay, that's it, that simple it is. So now what I'll do is, I'll write this expression in cout statement, I'll enclose it in brackets, and I'll also add endl at the end, and let's quickly compile and execute this code. You can see that in this case we are getting even as the output. So in this case, the given number is even. Okay, now let's change the number. Instead of 10, let's make it as 13. Let's see what we get as the output. So let me just compile and execute this code. You can see in this case we are getting odd as the output. I will say this is the first logical code that we have written. What we have done is, we have created a variable. In that variable we are putting some value, and we are checking whether that number is an even number or odd number. And what is logic for checking whether given number is even or odd? So basically we are using modulus operator. We are taking modulus of number with 2. Why with 2? Because in order to check whether a given number is even or odd, we usually divide the number with 2. If the number is completely divisible, we say that number is even. If the number is not completely divisible, we say that number is odd. So then based on that, we formulated these conditions. So if number mod 2, if it is equal to 0, we can say that it's an even number. If number mod 2, if it is equal to 1, we can say that it's an odd number. Now I have one simple question for you before I close this video. See, what changes do we have to do? If I, instead of writing evens condition, if I write odds condition, what changes we will have to do? So if I write, instead of equal to 0, if I write equal to 1, what changes we will have to do? It's very simple. See, if this condition evaluates to true, then output or result of this conditional expression or conditional operator is going to be operand 2, right? So when this condition evaluates to true, that means the given number is the odd number. So in this case, over here you will have to write odd, and over here you will have to write even. That's the only change that you will have to make. So I hope now you have got a clear idea about the conditional operator, how conditional operator works in C++. See, going ahead in the coding examples, definitely we will use this operator multiple times. So don't worry about this operator. It's going to be used multiple times, okay?